All right, here we go. Well, 10 years ago, we had a presentation on bookbinding by Richard, and at the time I had my own method of bookbinding that was somewhat different from his. And let's see, how do I get the next one here?
Spacebar. Don't put, not there, on the computer. Spacebar.
On the computer?
Or, here's wireless.
Huh?
Use the wireless.
Okay, where's...
Forward and backwards.
Oh, there we go. So...
it's infrared, so point it to it that way.
So anyway, the system that I used to use at that time was one that I sort of accumulated from library research, and basically what it involved was putting the sheets together and making hacksaw cuts, numerous hacksaw cuts in the spine, and then winding nylon thread. Of course, I'm an oboe player, and so we have lots of nylon thread hanging around, and you wind that back and forth, and then you smear glue in on top of it, and the result was just about like what Richard had. That is a book that it would never ever come apart. On the other hand, it didn't open very well. So this is a jig that I would use to make the hacksaw cuts. The metal strip helps, and I don't really do the hacksaw cuts anymore. But if you're going to sand the edge of your book to look real good, the metal strips are helpful. And here's your personal bookbinding system, your own personal tool. You always have it with you. It doesn't even require batteries. It's your personal, portable, handheld BBS, bookbinding system. And basically, that's all you need. Does anybody have a book they would like to have bound? If not, I brought one. Yeah.
There's a book in the works, I understand.
Oh. Well, okay.
Jeff does not have a book to be bound.
So you can also get some good, attractive cover art. So here's all your most popular guys. You know, you got the East Germans, the Department of Homeland Security. This is Hezbollah, I think. This one is Hamas. This is This is the Nazis, the North Koreans, the Internal Revenue Service. This is the Stasi, and this, of course, is the Iranian secret police. So you can always make attractive cover art, and people see that on the cover of your book. They're sure to notice. So now for the actual demonstration. Let's see, in here, a box. How about that, a box?
I like those books. Do you need that on the table?
No, let's take that.
I don't want to block anybody from seeing.
No, it's just a box. I think there's a book in here that is ready to be bound, and maybe some examples. Yeah, okay. Here's an example of a book. You see, this is what we end up with. Doesn't look so bad. Look how it opens up. You want to make a photocopy? No problem. Look at that. Here, pass it around. Let people have a look. And you can take this. You can take this this technique up to higher levels. You can make hard covers. Oh, here's another book. Now this one, what I did is I added a cloth strip around the. I had a cloth strip around the spine, but basically this is my WP34 manual that I printed out. So I don't think that's likely to come apart. And you can make hard covers using the same technique. So here's one, and what I did here is I made it a somewhat enlarged spinal pocket that would hold a pencil. So I'll do that to Richard for an example. Here's another example. same idea. This was intended to be my sister's diary. And it says it's the diary of Lynn Perkins. It says, including the darkest and most secret thoughts. And it says, no, Richard, who made this book, promises not to steal it, show it to Dad or the guys. There, you can pass that.
Can we go beyond the first page?
And let's see, hopefully, here's an envelope. Ah, here's an envelope. Here's a book. Okay, here's a book on discriminant use of discriminant functions in probability and statistics, right? So what I can do is I can actually bind this book verily as we stand here. So I'm going to the thing that enables it is this glue. It's called Aleene's Tacky Glue. All fabric shops have it. Michael's art stores have it. Any place where if a man goes in, he's likely to be attract a lot of attention for having a defective chromosome. But it's called Aleene's Tacky Glue. I'm not sure what it is.
Tacking, as in T-A-C-K-I-N-G?
Tacky,
No,
T-A-C-K-Y.
T-A-C-K-Y.
Pass it around.
Thank you.
Pass that one around. If you find it, sometimes you might find it's a little thick, no problem, just put a little water in it, it gets thin. And what I'm going to do here is an actual bookbinding job. Oh yes, sometimes it's helpful to have some advanced tools besides your personal bookbinding tool. These are useful. For those of those who are not American, these are used for solar-powered clothes dryers. And basically, you just first thing you do is make sure you got the spine on the right side, that everything is right side up. My paper will tell you some of the pitfalls of other methods and other approaches, like especially going to a professional bookbinder. So there's an actual paper on this in the proceedings. Okay, so I just put that on there.
Richard, maybe move over so that it's not behind the laptop.
So the camera can see.
So,
No, it's fine. We can't see what you're doing, which is why I'm here now.
okay, I got one clothespin on. Okay, there we go.
Thank you.
Now I just take that and put another clothespin on, a high-tech clamp, and maybe a couple more, just to make sure nothing goes anywhere. And that's good enough. Now I take my handheld personal bookbinding tool and
So where do you get that thing in your hand?
the
finger, sorry.
this one's never been opened. I'll tell you what, I'll put this out here as a raffle prize. Never been opened. I got another one in here. This is so okay now. Just slather that baby up, and just put a little bit in there, and
Have you ever used heat glue in an iron?
no.
Okay.
Now, what is it? What is this stuff? Well, if you will go to bookbinding websites, they all tell you to use polyvinyl acetate. And I don't know what this stuff is. I can't find out what it is.
It is. It's
But
polyvinyl acetate.
I found one reference, and I saw somebody using polyvinyl acetate, and it looks like that.
Yes.
That's what it is. Okay, so now you know. Aleene's Tacky Glue is polyvinyl acetate.
Carpenters.
So anyway, well, I didn't get the whole thing totally slathered up, but That's what the water is for. Cleans up with water, no problem. Now you have to admit that's what you call a minimal bookbinding system. When you travel, you should squeeze as much air as possible out of the bottle, just in case you go to a higher altitude. You don't want it to come gushing out. Now let's see what else is in here. What else is in here? Oh yes, the TI Model 30 MultiView, and I'm studying to pass the actuarial exams. And on the actuarial exam, is anybody from HP listening? There's only one calculator that it's allowed, and it's this piece of junk. $15 at Fry's, maybe 16. But still, there's a couple of things you can do with it, and since we already had a talk about solving, let's see, I think I have, where did that thing go? Yes, here it is. Here it is. It turns out I have a general method of solving that I will show you. But the main thing that gives a little bit of power to this thing is that you can scroll up to previous, you can scroll up and down to previously entered formulas, so you can recover past work, and then you can bring back a formula, and then you can edit it a little bit and execute it, and then repeatedly pressing enter just re-executes that same formula using answer, so you can do recursive stuff very easily. I'm sure the people that approved this for the actuary exam never intended that. Integration, besides solving, integration, no. I haven't found a way to do integration on it. So this is okay for the actuary exam. The most common thing you'll need it for is getting binomial coefficients. So what do I do? Suppose you want to double your money. You see, here's your 360 time payments of $1. It adds up to $360, and you'd like to get $180 up front in exchange for this time series. So you double your money basically. So what do? Well, it turns out you can rearrange that equation to get this, and it turns out this is much easier to key into the calculator than the 360 terms. You understand how you get this from this? Does everybody understand that? It's the single most important thing in financial analysis. Okay, so what I do is I enter in 0.9 or 0.99 or whatever. Don't use an illegal value. What's an illegal value? Well, if you put in 1, the divide by 0 police are going to come and pay you a little visit. So it can't be 1. And then you poke in that last formula using ants for the x. And then you repeatedly press enter. And generally, this applies to all equations that you might want to solve. One of two things will happen. Either the solution will converge slowly. So what you do is you increase this correction factor if it converges too slowly. If it oscillates, you decrease the correction factor. If it jumps wildly all over the place, you should consider changing the sign of the correction factor. But I mean, it's just a little bit of fiddling around, and you'll get your solution. It's not a thing where you just enter the formula and press go and you get the solution. And you got to fiddle with it, but it's a lot faster than pencil and paper, and it's a lot faster than having to write your own program solve. So that's basically the TI-30. You know, I don't know why the actuarial people insist on this. There's so many fine machines. You got the WP34 that has the normal and its inverse. It has I think it has a T and the chi-squared and all the nice distributions you would like to work with. But they won't go for that. They insist that you go with tables, and they actually give you the tables for the exam. Now, the other thing for those who want to take the actuary exam, whatever you do, don't show up with the lid for this thing, because inside the lid is a cue card that helps you use the calculator, and possession of that thing in the exam is considered cheating by the people that administer the exam. So I'll tell you what, I'll just leave this one on the, I'll leave this one in the rummage department here. Sort of at the low end, sort of the far low end here. Now, let's see how we're doing. By this time, this should be dry enough. This should be dry enough that we can take the clamps off. You see, it's sort of held together, but I'm going to just put another coat on there and just fortify the spine a little bit.
How much does the glue cost?
I think this much is about $3, and it's probably enough for a dozen books, maybe more, depending on how big the books are. So we just take that, smear it around a little bit. Uh-oh, it came apart at the end there. And so you just set it down, you know, hanging over the edge of the table is a good idea.
I'll put it on the cover.
No. And wash the old fingers off. My personal bookbinding tool, handheld, personable, portable bookbinding tool. So while that glue dries, let's see what else we have in here. Anyway, that's what that is. Now remember that here x in that equation is actually 1 over 1 plus I. So that corresponds to a periodic 5.3%. So now, some remarks on bad data. Okay, we have these fads. You know, one of the current fads in manufacturing and business is what they call the Six Sigma ideology. And the idea is that everything in life is distributed according to a normal distribution, and in a normal distribution, occurrences that are more than 6 standard deviations from the mean that just never ever happen. So, unfortunately, they actually do happen. There's many natural processes which are called heavy-tailed distributions, in which Six Sigma does happen. Let's see. So here we are. Here's an example that I was looking at. If you take a uniform distribution from 0 to 1, that's nice and well behaved, and then you take 1 over that, and you get something that it can go from 1 all the way up to infinity, and it's so badly behaved that the mean and standard deviation don't even exist. This mean and standard deviation are infinite. But you don't know that if you only have a finite sample of these guys. You don't know that, and so you have to take a good look at your data and try to and see, you know, what kind of a heavy tail, if you do have a heavy tail distribution. And of course, having a finite having a finite sample, of course, every finite sample has a mean, because all the numbers you have are finite, and obviously you have a finite mean and you have a finite standard deviation for every finite sample, no problem, right? So here's what I did. What I did is I took the cumulative mean. As the data came in, I sampled from a normal distribution, and I figured out what the mean is. And as you see, it starts down here. That's probably the first number, and then it oscillates, and then you see it eventually converges down. As the farther out you go, the less it fluctuates. Okay, that's a normal distribution. That's pretty well behaved. Now that nasty distribution that I showed you doesn't quite work that way. It tends to have these jumps, and then a sawtooth, and then jumps and a sawtooth, then a big jump and a sawtooth. So if you take your data as it comes in, you look for these jumps in the cumulative mean. So something similar happens with standard deviation. Once again, the normal distribution, of course we know this follows a chi-squared, and it has some initial large fluctuation, and then it settles down. Over here, that's not the case. Now I've adjusted this data so that the sample of all of my numbers would have a mean of 0 and a standard deviation of 1. So that's why this thing at the very end comes down to exactly 1. But it's the jumps that you're looking for. Now here's an interesting tail-heavy distribution. This is the Gossett student T distribution with 2 degrees of freedom. And once again, you see it has the initial fluctuation. It settles down, but it doesn't quite settle down. It maintains some fluctuation out there. And then once again, here's a natural process. Once again, it's sort of settled down, but it doesn't quite settle down. This is a stock market weekly going back to about 1950. So one of the places that you encounter these tail-heavy distributions is in financial distributions. So there's some less extreme cases. This is what the cumulative standard distribution looks like. You see, it's jumps and then decay, jumps and decays. That's a pattern. And this one, once again, it starts to decay, but then you see these little jumps, and those jumps are caused by very high magnitude outliers that don't occur in a normal distribution. So the Standard & Poor data, bottom line, it's tail heavy, but less so than the T distribution. I looked at some histograms. Okay, so looking at some histograms, you can see the same thing going on. Here's a T2 distribution, this inverted parabola. And you know from my talk a couple years ago that I like to take the log of the PDF, which for a normal distribution, this nice, beautiful, smooth parabola. And here you see the T2 has all these outliers. And also because of the outliers, usually you have a central peak that sticks up above what you get for the normal. And so the central peak usually goes with the heavy tail. And once again, here's the one over the uniform. Look, here's a point way out here at 9 sigma. You get a 9 sigma data point. The chances of that happening with the normal distribution, no, it just doesn't happen. And here's an unusual event. So much for the Six Sigma people. Here's one at minus 22.7 sigma. And in fact, this is a summation of the daily percent change of the Dow Industrials, going all the way back to 1885. This event, and does anybody know what it is? I remember it very. I remember it very well.
October '87.
Yes, you got it. You got it.
Oh, that's
The guy, the one guy at whom this talk was directed knew. Thank you.
You're welcome.
Namir.
Sorry, I had to go. Somebody, speaking of statistics, somebody was asking me about something I put on my website regarding regression, and I thought it was related to a talk here. So I said, "Ooh, little fire to put out." But he was abusing stuff I gave. I could not believe what he did to the data anyway. So
Yeah.
I sent him back the way it should be done.
So there you have it, a 22.7 sigma. I mean, you know, it's like, I mean, that's getting up there with Avogadro's number or something, you know. Anyway. So this whole thing is accumulated from 30,000 data points, that histogram, and anyway, that was of course that's not likely to happen now, because they put in rules that the market will be closed if it moves more than a certain amount. So that can't happen anymore. And then when the market is closed and you want to sell your securities, their value has gone all the way down to absolute zero, because you can't sell them, not even for 2 cents.
There was a joke then. It was the difference between a pigeon and a stockbroker. A pigeon can still make a deposit on a Mercedes.
All right. So anyway, statistics based on the normal distribution, not always applicable. Remember that the t-distribution is formed by a ratio of two independent random variables. One is a normal distribution, and the other one is a chi-squared. Okay, and the chi-squared itself is based on something that's normally distributed.
I think a sum of random.
Yeah, it's a sum of the squares of normal deviance. So statistics based on the normal distribution works fine for a lot of things in nature. I mean, if you're talking about things like, you know, like how tall people are, okay, there aren't any. No, you aren't going to find a 45-foot high man or a 2-inch high man. Things like that don't happen. So, for some things, for some biometric things, for example, normal distribution statistics are fine. But tail-heavy distributions, mostly in finance, in ocean waves, you've all heard of the rogue wave. That's an example. Flood data, war casualties, earthquake data, which is why I'm interested in moving here to Reno instead of staying where it's going to happen. So one of the things that they do is, like in New Orleans, they plan for a 100-year flood. One of the characteristics of tail-heavy distribution is that the next time your maximum of the last 100 years will be exceeded. It will not just be exceeded, it will be greatly exceeded. Because the farther out you go on the tail, the farther apart the data items tend to be. So, last month I went to the Skeptics Toolbox. That's every year in Eugene, Oregon, at the university campus. If anybody here is interested in science, analyzing science papers, critical analysis of science papers, that's a good thing to go. Also, it's kind of fun because along with that conference at the same time, there's a very entertaining conference, and one of the things we talked about was UFOs, and we had some good examples, and in fact we had a workshop on how to photograph UFOs for proper documentation, and so the only camera I had on me was my cell phone, but here's some actual UFO photographs. And those are actual UFOs. It's probably hard to see if the lights could be lowered.
That's a TI-30.
No, it's not.
Somebody's tossing it out like that's no good.
No, it's not being tossed. Take a good look at it. I mean, yeah. Okay. And it turns out with the result of that and some other I mean, right over the University of Oregon campus, can you imagine an actual UFO? And we were actually able to determine some of the physics by which, some of the physical processes by which these things were able to levitate. See, that's part of the levitation system there in the upper left. Now the essential thing, if you're going to photograph a UFO, whatever you do is don't let it get between you and the building, because that'll be a giveaway that it's something close. And this was an actual UFO. We later identified it as a coffee pot lid. But this is how most UFO, I mean, you know, if you watch the History Channel or anything like that, this is mostly what you get. And then on the way home from that, of course, I did have to stop in there. Has anybody ever been past this place?
What's the name?
Yeah.
Then you know that the parking lot on the right side is for a different business, right?
Actually, I didn't, but I have been there.
So I didn't want to photograph any of the cars off in the right parking lot because I didn't want to visit from the mafia. And then here's a picture.
Oh wow!
That's me on Wednesday with her being the photographer. That's the Owens Valley Radio Astronomy Observatory. There's two facilities there. One is operated by Caltech and one by the National Science Foundation. Anybody going down the Owens Valley to go back towards Los Angeles, go down 395 and stop there and look around. Interesting stuff. And
is the glue dry yet? If the glue's dry, I check it, Richard.
Is the glue dry?
Yeah, it's dry. The glue's dry.
Let's see. Yeah, it's still a little sticky.
Well, your time is up.
Is my time up?
Yeah.
Really? Okay. Well, there's things about harmonica that most people don't know, and many of you don't want to know, like why all the notes aren't there and how you make notes go flat and sharp and things like that. Anybody who's interested, ask me privately.
Or you're going to pass that around or something? I just don't touch the glue.
Any questions?
Any questions for Richard? Now, just to keep it clear, because Tim was being Tim, and Richard's system is better than mine, and I'm not going to argue that point. You had a very nice quote in your presentation, in your printed presentation.
Yeah.
The second last sentence in your presentation.
What was that?
That was about me, and the first version. Why we're in competition? No. Did you?
I know you like this because you don't have to spend money on staples.
You gotta buy glue.
Yeah, that's true. But
okay, so
Question?
yes, for Richard.
yes.
Yeah, for Richard.
Huh?
Does this presentation fall under the CDA also?
NDA.
I don't know. I don't know.
That's the guys on the left.
But there's an article in the proceedings on the flash drive that you got that tells you everything I know about it. And I'm not saying I've learned everything there is to learn, but
UFOs.
the UFOs, you can make your own UFO.
The NDA on this agreement. UFOs.
The what?
On the UFO you showed us, a technique of the UFO. Does it fall under the non-disclosure agreement too?
As a reminder,
I was gonna ask about the sales figures for the new version of the WP-34. I was gonna ask the same thing. That's Richard.
Richard.
Yes. Other question. What?
I'm curious how durable that binding is. If you generally use 2 coats of glue or more, or what can you say about that?
Usually, well, in this one, because it was kind of big, I clamped it together and then I just put dots in between the clothespins. And then I smeared a heavy coat all over. But when it dries, which will be probably in about 2 hours, it'll be as durable as any paperback book you'll ever find.
staples have 0 drying time, by the way.
Yeah, but the staple books do not open nicely for photocopy.
But you have to do the booklet method to have the individual little sub-booklets, right, to get it to work really nicely.
I mean, look at that. You can lay that on a copier. You can't do that with a stapled book. You see, it's not coming apart.
What's the smallest number of pages on the page you can find there?
The smallest number of pages you can do it to? 2. All right. Richard has spoken.